Alright guys, now let us look at this example right here. Obviously we can see that it is a ratio of two functions. The numerator is an exponential function of the form b to the power some x. In this case it's 3 to the power x squared, and then the denominator is just a quadratic function, an algebraic function. So guys, in order to find the derivative of this function, we can see that it is a quotient. So we got to start by using the quotient rule. So using the quotient rule, what I'm going to do is I'm going to identify this as f and this as my function g, numerator, denominator, and let us quickly remind ourselves the general form for a quotient rule. Guys, it is f prime times g minus g prime times f, and you got to divide by the square of the denominator. So using that, let us go start applying this. First of all, we have to write the derivative of the f function. So guys, this is an exponential function of the form b to the power x. But it's not just to the power x, it's to the power x squared. So one has to use the chain rule here as well. So the derivative of this is just going to be the exponential function itself. That is always the case, right? And then you got to multiply by the ln of the base, which is 3, ln of 3. But you still have to multiply by the derivative of the exponent or derivative of the inner. In this case, the exponent, guys, is x squared. And what is the derivative of x squared? Using the power rule, it's just 2x. So I'm going to multiply this by 2x. That takes care of the f function. I still have to multiply this by the g function. And g is a binomial, so I'm going to put it in parentheses. That takes care of f prime times g, then minus. Let us see what we have to do in the second piece. G prime, the derivative of the g function, it's a simple algebraic function. X squared, the derivative of x squared is just 2x. And derivative of 1 is 0, don't need to worry about it. And then, guys, I'm going to multiply this by the f function. I'm just writing it in the parentheses. You don't really have to write it in parentheses, but I mean, if you like, you can. So that takes care of the numerator. We still have to divide this whole thing by the square of the denominator, which is x squared plus 1 whole square. Let us see if we can simplify any further. So guys, what I'm seeing here is that there's a greatest common factor because there's a 2x and 3 to the power x squared here, and I can see 3x squared and 2x right here. So what I'm going to do is I'm going to take outside the greatest common factor, and that is usually what we do when we see a greatest common factor. We take it outside and then we have something left in the parentheses. Let us see what is left inside the parentheses. So guys, in the parentheses, I'll be left with x squared plus 1. I'm going to write that first, and then ln of 3, and then here I'm just going to be left with minus 1. Right, guys, this whole thing has to be divided by x squared plus 1 whole square. I think that is the best we can do here. Sometimes people like to leave the final answer like this, which is also fine. But guys, if you are trying to do this from a textbook or somewhere and the final answer does not look exactly like this, because sometimes people like to take out the greatest common factor and they like to simplify stuff. So guys, you may see something like this. That is why I went ahead and simplified this. And I like to simplify things as much as we can. So that was the other reason why I didn't leave it like this. I simplified one step further. But looking at this, it seems like I cannot go any further than this. So we just stop here. So guys, this was another example on exponential functions. Guys, I'm trying to show you different types. This was a quotient rule. The last one was a product rule. Then we had some simpler ones, a combination of two. So I think I'm going to show you one more example on the exponential functions, and then we are going to move into the derivatives of the trig functions, which is also very important and very useful. Okay, till then, take care. I will see you in the next video.